So now let us try to understand the characteristics of this law, universal law of gravitation. Children, as we have discussed that the force acting between these two bodies, are these two bodies kept in contact? Are they kept at some distance ahead? So there is no contact between the two masses. No need of any contact between in order to act the universal gravitational force, whatever is acting between two bodies, there is no need of contact between the two bodies. So this law of gravitation, the force between the two bodies, okay, can be acted when the two bodies are also kept at a distance. Hence, first characteristic is that this force is also called as force at a distance. So, coming to the characteristics of force due to gravity. Okay. So, or simply characteristics of gravitational force. Characteristics of gravitational force. So, gravitational force is nothing but it may act throughout the universe. Between any two particles in the universe, some force of attraction acts between them. That is called as your universal law of gravitation, and the force that acts between those two particles is called as force due to gravitational force. It's called as gravitational force. And now let us discuss in detail regarding those characteristics. So what is the first characteristic, children? So there is no need of any contact between the two bodies. No need of contact. So this force can also act when two bodies are separated by some distance. Hence, first characteristic, as there is no requirement of any contact between the two bodies, this force can also be called as force at a distance. So, what is the first one? Force at a distance. So, this is the first characteristics. First characteristic means the force, it is also called as force at a distance because there is no requirement of any contact between the two bodies. Moving to the second one, as we have observed that this force and distance between the two bodies, they are inversely proportional. Okay, F is inversely proportional, isn't it? F is inversely proportional to the square of the distance between them. Inversely proportional, but to the square of the distance between them. Hence, second characteristic, it can be said that inverse square law. Okay. So, what is the law, children? The gravitational force between the two bodies varies inversely proportional to the square of the distance between them. Hence, gravitational force is an inverse gravitational force. Okay. So, what is this called as? Inverse square force. Let us consider as inverse square force. Why? Because what is the reason? Because it is inversely proportional to the square of the distance between them. And third case, as we have discussed that if the second body attracts the first body with some force, say F1, and first body attracts the second body with some force. Okay, the force acting on the, I'll write it something like this, M1, and here it is M2, some line joining between the two. Yes. M1 pulls the second body with some force, say F1, and M2 pulls the first body with some force, F2. Force acting on the first body due to M2 is F2, and the force acting on the second body due to the first body is F1. Okay. So, very clearly, so if whatever the force it is pulling, the same force is applied by the second body on the first body. So clearly we can say that the magnitude of the forces F1 and F2 are equal. So equal and opposite forces are acting. Okay, direction is opposite. The direction of the first force is in this and the other body, due to the first body in one direction, due to the second body in the opposite direction. So direction is opposite, but magnitudes is same. So we can conclude that these forces, the gravitational force, forms an action-reaction pair. So what does it form, children? It forms an action-reaction pair. So it holds good with Newton's third law. If action is taken place on first body, reaction force will be taken on second body. So they will form an action-reaction pair. So what are the three main characteristics of gravitational force, children? First one, force at a distance. It can be considered as a force at a distance because there is no need of interaction, no need of contact between the two bodies. Second one, as force is inversely proportional to the square of the distance between them, it can be also called as inverse square force. What is that called? Inverse square force. And now the third case is all about, it forms an action-reaction pair. The two forces acting on each other is magnitude is equal but opposite in direction. They are acting on two different bodies. Hence, holds good with Newton's third law. Okay, children. So, I hope the concept is clear. So, before moving to the next concept, let us recall back everything regarding the universal law of gravitation. So first one, what is an orbit, children? The path followed by the planets, revolving planets around the sun or revolving satellites around the planet itself is called, that path itself is called as your orbit. Okay. So Sir Isaac Newton formulated the relation between the universal gravitational force and the different objects. So what exactly he says is, according to the Newton's law of gravitation, universal law of gravitation, he says that every particle in the universe attracts every other particle with a force which is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Product of the masses and inversely proportional to the square of the distance between them. So altogether it can be written as F proportional to m1 m2 by r square, or when proportionality symbol is removed, F is equals to G m1 m2 by r square, where G is called as your universal gravitational constant. And the value of G always remains constant throughout the universe. So its value, hence it is also called as gravitational constant. Why? Because its value throughout the universe remains constant, and the value is given as 6.67 into 10 power minus 11 Newton meter square per kg square in SI system. So how much is that? 6.67 into 10 power minus 11 Newton meter square per kg square. The same can be calculated in CGS system, children. So in CGS system, it can be calculated as something like this. The value of 1 Newton in CGS system is dynes. So how many dynes? 1 Newton is 10 power 5 dynes. And so units are Newton meter square per kg square. Newton when converted in dynes, 1 Newton is 10 power 5 dynes. Meter in CGS system is measured in centimeters. So 1 meter is 100 centimeters. So this implies 1 meter square is 100 square centimeters. So this is 10 square centimeters. Similarly, kg. In SI system, mass is measured in kg. In CGS system, it is measured in gram. So 1 kg equals to 1000 gram. It can also be written as 10 power 3 grams. Hence, the value of 1 Newton meter square per kg square in CGS system can be written as 10 power 5 Newton in 10 power 5 dyne meter. 1 meter is 10 square centimeter. So 10 square meter square indicates 10 square whole square centimeter square. Meter is 10 square centimeter, meter square is 10 square whole square centimeter square upon kg. Kg is 10 cube grams, kg square means 10 cube whole square grams. So simplifying further, so 1 Newton meter square upon kg square can be given as 10 power 5 multiplied by 10 square whole square is 10 power 4 upon 10 cube whole square is 10 power 6. Units are dyne centimeter square per gram square. Kg square, so gram square. So 10 power 5 multiplied by 4 is 10 power 9 upon 10 power 6 is 10 power 3 dyne centimeter square per gram square. So 1 Newton meter square per kg square can be written as 10 power 3 dyne centimeter square per gram square. Therefore, the value of G in CGS system can be written as, in CGS system, the value of G can be given as 6.67 into 10 power minus 11 in SI. So, instead of Newton meter square per kg square, I have to replace it with 10 power 3 dyne centimeter square per gram square. Minus 11 multiplied by 3 will give you a result of how much is that, children? So, the value of G in CGS system is 6.67 into 10 power minus 3 plus 7 is minus 8 dyne centimeter square per gram square. So, in SI system, the value of G is 6.67 into 10 power minus 11 Newton meter square per kg square, whereas in CGS system, its value is found to be 6.67 into 10 power minus 8 dyne centimeter square per gram square. Is that clear, children? So, children, we know that every body attracts every other body in the universe. Similarly, Earth also attracts other bodies towards itself. So, it attracts. This force is called as a gravitational force. So, the gravitational force of the Earth on other bodies is called as gravity, or simply called as gravity, or in detail called as your acceleration due to gravity. So, what do you mean by gravity or acceleration due to gravity? The gravitational force with which Earth pulls the body towards itself, indicated with the letter G. Okay. So, the value of G is acceleration or acceleration due to gravity equals to, on the surface of the Earth, is 9.8 meter per second square. Also remember, children, you also need to know one more relation, that is 1 kg weight. What exactly is 1 kg weight is? Always remember the value of 1 kg weight as 9.8 Newton. So, what is the value of 1 kg weight? It is 9.8 Newton. So, how it is means 1 kg. Here 1 kg indicates mass. Weight indicates that acceleration due to gravity. So, 1 kg weight indicates mg. Mass into weight. So, m units is kg, weight means gravity units is meter per second square. 1 kg, 9.8 meter per second square. So, this total 9.8 kg meter per second square itself is written as Newton. Okay. So, this part you need to know, children. This is applied while solving a few numericals. So, what is the value of 1 kg weight? The value of 1 kg weight is always equals to 9.8 newtons. And how? I have explained here. Okay, children. And always remember, children, the value of universal gravitational constant is 6.67 to 10 power minus 11. So, 10 power minus 11 indicates that it's a very, very small value. Hence, as the value of universal gravitational constant is very small, we can conclude that this gravitational force is very weak force. We have many forces in nature, many basic forces in nature. Okay, so this is a weak nuclear force, strong nuclear force, gravitational force, magnetic force, some electrostatic force and all. So among all the basic forces in nature, gravitational force is considered as the weakest force because its value is very small. Okay, children. So now, and this value, the value of gravitational constant, universal gravitational constant, was found by Henry Cavendish by his experiment, Cavendish experiment. This Henry Cavendish has calculated the exact approximate value of G as 6.67 into 10 power minus 11 Newton meter square per kg square. And this value is itself is a constant value. That means this value remains constant throughout the universe. Throughout the universe, the value of G is always constant and it takes the given value. So children, now let us move to the next topic, children. And this is all about the importance of this universal law of gravitation. So now the next topic is all about the importance of universal gravitational constant. And we have no characteristics of gravitational force. What are the three main characteristics of gravitational force? No need of interaction between the two masses. So it can be said as force at a distance is inversely proportional to the square of the distance. Hence, it also called as inverse square force. And the force with which the first body attracts the second body is always equal to the force with which the second body attracts the first body. Hence, they form an action-reaction pair. So, goes good with the Newton's third law because these forces act on two different bodies. They are equal in magnitude but opposite in direction. So, F1 is equals to F2.